Lesson 1 in Module 7 is on the Pythagorean Theorem. Now, we've talked about the Pythagorean Theorem in our warm-ups. You've kind of like seen it before, and now we're really going to dive into what it means. Excuse me. And then we're going to use our answers to really get into like square roots and simplifying radicals and all that good stuff that's coming this module. So, Pythagorean Theorem, okay? The Pythagorean Theorem is for it has to be a right triangle. Okay, so a right triangle. And it's for missing side lengths. Sorry, I'm so sloppy. It's not working with me today, but I normally am, I know. Okay, and we'll get into later how there's an if-then that goes both ways, kind of the converse too. But here's what it is, okay? A squared plus B squared is equal to C squared, okay? A and B here are what we call the legs of the triangle, and C is the hypotenuse. Okay, and basically it says this: if it's a right triangle, then the square of the sides around the right angle, a squared plus b squared, will equal the square of the hypotenuse. The same can be said when I said it means the opposite is if this is true, then we can say it's a right triangle. We'll talk more about that later, okay? But this right here is what we're using today. Okay, or that right there is the Pythagorean Theorem. Okay, so it says write an equation that allows you to determine the length of the unknown side of the right triangle. Right triangle, missing side length. Okay, so as soon as you think of those two things or see those two things, we're doing a squared plus b squared is equal to c squared. You have to identify your c. So what I'm going to tell you to do is always find this box, right? Because that means it's the right angle. And the right angle is going to be the largest angle in the triangle. So the hypotenuse is always going to be the longest side. And it's always going to be across from the right angle. Okay, so this is the hypotenuse. And that is always C. A and B don't matter. You can say this is A and this is B, or this is A and this is B. It doesn't matter because we're adding them. And we know the commutative property says we can add in any order. Okay, so I'll say A is 4 and B is 9. And I'm going to go 4 squared plus 9 squared equals C squared. And I want you to really work the equation straight down, okay? So 4 squared. 4 times 4 is 16. 9 squared, 9 times 9 is 81. That equals C squared. Don't add those together and move it to the right. Keep coming down. Now, grabbing my calculator here. 16 plus 81 is 34. So this is 34 equals C squared. Now, this doesn't mean that the hypotenuse is 34 centimeters. If this is 4 and this is 9, 34 is way too big, okay? Now, we've talked about in the past using the square root symbol that undoes the squaring, okay? So if you remember that, go do that. But I want to point out in this lesson, we're really just working on approximations, okay? So basically, C squared means C times, what number times itself equals 34, okay? Well, if you think about this, if you start doing some examples, right? If I did 5 times 5, that's equal to 25. If I did 6 times 6, I mean, this is 5 squared. These are called perfect squares, 6 squared, right? That's 36. Well, notice 34 is really close to 36. So we could say that C is approximately equal to 36 centimeters. It's not going to be exact. And in fact, if I put my calculator up here, we'll see what calculator I have up. If I took the square root of 34, all right, so again, you've seen this before, that radical symbol. It's approximately, oh, you totally see me messed up now. 5.8, right? 5.8. How did I mess up? Because C is not going to be approximately equal to 36. Testing you, right? It's approximately equal to 6, okay? Because we were saying what number times itself is approximately 34. Well, that's 6, and this makes way more sense, okay? I promise I'll get better as we go on here, okay? So we can see that the approximate answer is 5.8, which is approximately 6, not 36. All right, let's look at another example. Write an equation, and it's not saying solve, but I'm solving these out. It allows you to determine the length of the unknown side of the right triangle. Missing side length, right triangle, Pythagorean theorem. A squared plus b squared is equal to c squared. Now again, you have to identify your hypotenuse. Don't just assume everything's a and b. So here's my right angle. I look at the side across from it. Oh, look it. C is equal to 13. Okay, so don't panic when you see that. Pick one side to be A, and then I'm saying that says A is equal, and one side to be B. Again, it doesn't matter which one. So A is 5, so I'm going to say 5 squared plus B squared is equal to C, which is 13 squared, 13 to the second power. Well, 5 times 5 is 25, plus B squared is equal to 13 squared is 169. Okay, solving an equation. We know how to do that. I'm solving for b squared, so I start order of operations backwards. I get rid of whatever is being added onto it or subtracted from it or whatever. That's this 25. So it's a positive 25, or, you can think of it as plus 25, minus 25, positive 25, negative 25. That's 0, and I'm left with b squared equals 144. Okay, so what number times itself equals 144? Well, 12 times 12 equals 144. Okay, you could guess and check some if you didn't see that. So we're going to say b equals 12. In this case, it's exactly equal to 12, not 144. Okay. All right, so that's what we're working on right now. Let's do one more example. Write an equation to determine the length, and I'm going to solve it, of the unknown side. Length of the unknown side, right triangle. I think Pythagorean theorem. A squared plus b squared is equal to c squared. So again, find your right angle, look at the side across from it, that's c. Okay, so you can see in this case, sometimes we're missing the legs, and again, the legs are the sides that make up the right angle. That's what we were missing here, right? This side is a leg and this side's a leg. And sometimes we're missing the hypotenuse. So I'm going to say A is 8, so 8 squared plus b is 3 plus 3 squared is equal to c squared. This is not 8 times 2. It's not 8 plus 8. It is 8 times 8. 8 times 8 is 64. Plus 3 times 3 is 9. That equals c squared. If you add 64 plus 9, you get 73. So you have 73 is equal to c squared. And again, what number times itself equals 73? Try some. Let's see, 8 times 8, okay? So 8 squared is 64. 9 squared, which is 9 times 9, is 81. All right, so 73 is going to fall in between those. Kind of falls right between them, right? Let's see, it's 9 away from 64, and I think it's 8 away from 81. Yeah, so I'm going to say it's a little bit closer to 81, which means that C is approximately equal to 9. Now again, if you did the radical method, where you took the square root of 73, you'd see it's 8.54. Well, guess what? That would round to 9. Okay? And these are centimeters. Now, I'm not going to be concerned with which way you do it, okay? Because our goal right now, and we're going to start working more with these radical later, but what the goal right now is to understand what it means to be a number squared, okay? And that's where our focus wants to be. And we're going to use Pythagorean theorem to kind of introduce us to that and start working with it.